All right, so this is a video of a collision, and if we go forward frame by frame, we'll see the collision happens right at 0.4 seconds. That's when it starts to occur. When you collect your data, make sure you're collecting your data after it's out of the person's hand, yet before it makes that collision. All right, what we're trying to study is conservation of momentum, and we want to know what was the velocity right before impact and what was the velocity just after impact. Okay, so there's a brief instant where the two are colliding, and then they start moving together. All right, so the collision, if in this video the collision happens right around 0.4 seconds. If we scroll down and look at the data, right? If we turn off our curve fits, you can probably tell where the collision happened because the slope of the points changes drastically right around 0.4 seconds. So what you want to do is, as carefully as you can, collect this data, and then, if there is a little bit of friction acting on the car as it travels across the track. So it's a little bit of a mistake to take the distance it travels the moment it's out of the person's hand until it reaches the point where it collides, because then you're finding an average velocity. What you want to do is probably do a linear fit, but only for a couple of specific points. So what you want to do is deselect every point except for maybe 2 or 3 points just before the collision. Now, I'm not sure exactly what time this video, what time the collision happened in this video, but let's just say the collision was at 0.4, so we don't actually want that piece of data. You might choose, 2 or 3 data points, maybe even just 2, right before the collision, and notice the slope, y equals ax plus b, I get 0.800 meters per second. So the velocity was approximately 0.800 meters per second just before the crash. And then I would use a couple of data points just after the crash to figure out what was the velocity of the two cars moving together after the collision, right? So now we can see if I use just a couple of data points, I get 0.500 meters per second, 500 thousandths of a meter per second. So my slope has decreased quite a bit. It's moving slower, and that makes sense, right? They're going to move slower after they've collided together. The question is, using your judgment, should you use 2 data points or 3 data points? But the one thing you don't want to do is, use the end data point. Notice now I've got 0.475 because I'm getting an average velocity across that entire span after the collision. If I just use the last couple of points that were collected, I get even a lower slope, 0.450, right? So that's not what we're looking for. We're looking for the velocity immediately before the crash, which in this case would be just before 0.4 seconds, and immediately after the crash. And those velocities will help us investigate whether or not momentum was conserved.